world. Hello Twitch. Hello YouTube. Hello everybody. This is episode number 18 of building Game Boy Emulator with Rust. So let me just announce the streaming on my Twitch, on my Twitter. Just 1 second. Let me see. Okay, now everybody knows that we are live. So yeah, hopefully the sound is good. And yeah, yesterday I had to finish the streaming earlier because today I have more zoom the screen. Let me just put a little, like not too much. Yeah. Okay, this way is better. Just there. My cat's food. Yeah, that's it. So let's start. Yesterday I had to leave earlier because my daughter was sick, but thanks God everything's okay now. I think she ate something that make a mess in her stomach, but now everything is good, and we will be able to do this stream and hopefully to the end at least 2 hours. Oh, I think next week, maybe next 2 weeks, I will be doing streaming. I will be streaming like more because I will be traveling and I will be far from my family anyway. So maybe I do more streaming, and even in the next weekend, not this but the other one, maybe I will do some streaming on the Saturday and Sunday, just because I will be alone there anyway. What else? Yep, that's it. So let me see here. Let's get started. So yeah, so welcome everybody. And yesterday we starting doing this refactoring on the viewport, and and also I just saw my microphone. Maybe next week I will also improve our gears here to getting a better microphone, and yeah, let's see. So what we did yesterday, we started with this rasterized tile set, and this tile set is now filled by the function rasterize entire tile set, which is called by the write byte in the memory management unit when the address is around the address. Oh, I think I closed it. Our PyBoy, which is a very good source of information. Yeah. Here we have it. Yeah. So when the data in between these two, this area is being written, which means that our cartridge is trying to write the tile data. When this is done, I will rasterize the entire tile set. I put a little to do here. Hello. Hey Douglas, have you thought about reaching out the Rustation Station podcast host to see about doing an episode on this project? I only do their audio, but they might be interested in take to you about. Yeah, I actually was. I had those. I thank you for that, Aaron. IRL City Music. So I Patreon. I got. I was they are in my Patreon list, so I was like giving them donations, giving him to donation. It's hostation. It's hostation. Yeah, something like that. I think so. Rustation podcast. Google is always better to fix our errors. Yeah, new Rustation. But Patreon said to me that they stopped it. I mean, he even contacted me asking me if I want to put some link, but it was before I start streaming. So I said, oh, maybe I'll have this when I start streaming. Then we will talk about that. Yeah, this is his Patreon. Yeah, Chris. But I don't know why. They said that the show was not being done. When was the last episode? Oh, yeah, 27, May 27. Yeah, definitely. I will talk to him. I mean, I can reach him, but I think my project is still very. Oh, host stations. That's a new one. Oh, that I don't know. Sorry. I was thinking on this one. Rustation station. Oh, a community project for creating podcast. Oh, this is very early too. This is interesting. Thank you, IRL City Music. I will try that. I will put this here in my folder, which I'm always working on, and I will talk to them. I follow them in Twitter. Yeah, that's great. New Rust content is always great. Perfect. I will talk to them. Oh, you work for them? You do the music for them? Aero City, and your nick is Aero City Music. Maybe you have the contact to them. You can like show them this stream, and I'm interested to participate or to show something if they want to. John, I know this name. Oh yeah, I follow him in YouTube. Definitely, this guy is. Yeah, I like those videos. John Ginsat. I really like his videos, and he's inspired me to do this actually, because he is one of the few guys that streaming or have videos about Rust, like live coding, and that definitely inspired me. You should totally. Perfect. I will do that. Thank you for that, and I will definitely do that. I even follow him in. Oh, I didn't follow him. Oh, I definitely need to follow. Yeah, I will do. I will contact them. I will contact him and check if we can like show something. That will be very nice. Thank you for that, Arrow City. Okay, so yeah, that's good. Getting back to our project. So I'm writing now. When I write data on that specifically area, I will rasterize the entire tile set. That even doing that only when write that data, it's too much. We don't need to rasterize the entire tile set, but I'm just doing that now to be fast. I mean, to be fast in terms of development here, because otherwise I need to understand which tile is being modified and only modify that tile inside the rasterized array tile set. And that could be, I mean, it's not too hard, but I will let this way for now. And oh, actually, this should be done after we write. Yeah. Okay, so now that we have this done, transform background buffer. No, this is not the problem. The actual problem is here, populate. Yeah. So now we don't actually need to get this. So the get tile set, so let me just double check here. We are using just get tile here. Okay. Now get tile set, and again this tile set. Oh yeah. Oh yeah. So actually, this get tile set is using get tile, which reads 16 bytes for each tile, and that's why it's only going to 256, because it's 256 tiles per area, like this. Are we seeing here? So that's why. But in this case, we should not read from the here anymore, but we need to read from our rasterized tile set because we already have it. In this case, what we need is just let me check if I understand here what I did. I think this was wrong, because if this is the first address and it is summing up here, this should not be times 16. Oh yeah, it should, actually it should, because it should get the next 16 next to 16, yeah. It was right. But now I don't need it, I just need to get it from here. And actually, I don't even need this. Let me understand. Because our rasterized tile set, and sorry about this briefing, like a here we are getting the tile, rusting it, and put it here. So we already have the tile set here. So we don't even need. I mean, if we use this get tile set, I would just, and I will return a vector. Actually, of U32, and this will be self rasterized tile set, right? Why is that? What's the problem here? Oh, sorry. That should be okay. Yeah. So now we have this, and actually here I don't need to get. So the tile set, I don't need to use this here actually, because I can just, oh, there is one point here. Yeah, here I just need to do this. Rasterize. Oops, sorry. Self-rasterized tile set. As this tile map item is an address, a memory address on the RAM, it still is like this. But our index in our tile set is now starting from 0 because we did that way. So I just need to do something like this. So if it's 1000 8000 hexadecimal, it will be 0 and so on. So that's fix our issue. our tile is a red rasterized, so we don't need to do nothing here. We do tile here, and we should be good. What's the problem here? Oh. Oh. Wait a minute, because I think that maybe so a tile is raster tile is okay. Oh, I am already putting as a pixel here. Okay, so there populate. Yeah, we should still do that. Okay, then we don't need this. But our map actually I need to get a range here, which is okay, let me do something here. Let rasterize tile set index equals to. So let me explain what I will be doing here. Just to okay. So then I don't need to do this. Yeah. This way I can then get a slice. So now yeah. So now what we have here, just to be clear what we are doing here, we have first we create this rasterized tile set index as the tile map item minus 1000x, because it's starting in 1000 and our tile set, rasterized tile set, starting on 0. So that's the first case. That first point. Second, we are getting, because our rasterized tile set is a red spread the pixels, so we are just a vector of U32. So our rasterized tile set is not made of tiles. I mean, it's not separated by tiles, but it's already in pixels. So it's a sequence of 16 by U32, which is 1 pixel in the minifb format. So for getting one tile, oh, it's not 16 but 8. So for getting one tile, I need actually 9, because yeah. So let me explain. I need to start the range from the index that the tile map item points and goes to plus 8 pixels. Why I'm adding 9? It's because the range on Rust do not include the final point. Then we have the tile. Now this should work, yeah, because tile is now a slice of a vector. Then we can have the iterate and enumerate, and this should work. So now we have the populate. Yeah, makes sense. We are still doing 2 loops in this populate background buffer, which we only need to do when the tile views change. But let's see if this is still working. Okay, so let me see if this is still working. Well, cannot borrow as mutable. Okay, where is that? Oh. Yeah. So now I have a mutable reference, and that's a problem. Let's see if the compile will compile. No. Where is that? I don't know if this is way. Let's see. Yeah, I know that will not allow us to do, because, well, we have this immutable ref borrow occurs here, mutable borrow later. So wait. Yeah, this is getting hard. I know that this part of Rust, when you have, I mean, this is the most different part of Rust, and the most safety part of Rust, the ownership model. And the problem here is that inside the memory management structure, I need a mutable reference of PPU because I want to call that rasterize method, which is a method of PPU, a mutable method of PPU, which will mutate the state of that PPU. So that's why I need a mutable self. And then I pass in a memory management unit, but I do not understand here. That PPU equals to self PPU. Just to see one thing. Where it will complain. Yeah, now it complaining here. Yeah. Now it's complaining here. Yeah. And why it's the problem? What's the problem here? Oh. Now, I think I can change this to be. It doesn't need to be mutable. No, but that. No, that will not save. But why? I'm just getting a mutable reference to the PPU, not to the MMU. Let me check here. That MMU equals self. I'm just playing here to see what's the errors. Okay. And now what's the problem? Oh. Oh, now I understand. I got it. Yeah. Self here. Now I got. Self here is a mutable reference to okay, so here at this point we solved the PPU issue. Now we have a MMU issue. Why? Because this self is actually a mutable reference to self, to memory management unit, to MMU struct. And cannot borrow self as immutable because it's already borrowed. Okay. What if I set this as mutable just to see what is happening now? Oh, then it's this. Now what's there? Oh yeah. Now the problem is that it's mutable here. That I don't need that to be mutable. Let me understand here. I think I need to use something else, but let me understand. The problem here is in this scope, so here I already have a mutable I mean MMU is already a mutable reference. In Rust, I can have only one mutable reference and any immutable reference. But if I have one mutable reference in that scope, I cannot have any other reference. So as this function, this method, is being called in a scope that I already have other immutable mutable reference, I cannot borrow I cannot borrow self to this function as a mutable, as immutable. And even if this is a mutable, I cannot have multiple mutable references. So, how to solve that? First of all, let me see if this is the best way of doing this. Okay. Okay. So in the way that we did, I still need. So let me check one thing here. I think there is this. I found this sheet. Sheet. So reference and pointers. Okay. Let me get to the Rust book because I have this. The box. Smite pointers. I point blah 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 blah. For allocating values in the heap. A reference counting that enables multiple ownership. I think it's something like this. No, I don't think this is. Yeah, but I think I don't need to do this. I think there is other ways to do this. One of those are letting this method. Well, this method should be in PPU. Okay. I have some doubts here on how to solve this. Yeah, but this case itself, I think there's something. I feel like there's something wrong with the way I'm doing here itself. If I move everything from here to there, if I move this, let's try that. But it feels wrong then in the design, but well, I will need this. Oh, I will need a lot here. This is not mutable, and this is not mutable as well. Actually, this is just reading the bar. This is actually doing something. Why do I need? I need to cat. But it could be the other way around. Let me try something. I will remove the PPU from here. Yeah. Okay. So now I remove the PPU. Who you? Oh no, it's not needed. Of course we wanna fail because we don't have PPU. Yeah. Then I will need to do something here. Well, let me just. So I'm putting it back here. Okay. But I will do something like, let me just see how this works. South pub. So pub pasteurize entire. No, sorry. Yeah. Call PPU pasteurization. Let's do this. Self. Just self. And then put it here. Self. Okay. Yeah. Let me just try this. Self call. then now this could be. Now understood. This is. So let me try one thing here. Pub function get PPO self. Oh, I always need a mutable reference for the. Oh, that's rare. Struct mutable reference field. There. Why I can mutate it through immutable but not through immutable? If I have an immutable bind to a struct that and that struct contains a field that's mutable reference, I can mutate the referred object through that. So let me understand here. So, as a so now I have a mutable reference for something. Okay. And then if I get it works. But if this is a reference, I want to bind to. So maybe I can have one answer here. Okay, so if I do that here, if I do that, m equals to self. Oh, this should be mutable. Okay. Okay. And then y self. If I do this. this case, note expected and then receive it. Okay, if I do this, I cannot move. Is there this? Is there something like this? That's weird. So if I do pub function get PPU, and I just return like PPU. That's it. Self PPU. Yeah, that works. Why that works? That's a mutable reference. I'm returning. This is weird. So if I do just this, I don't receive anything here, and let PPU equals self PPU. No, self get PPU. What's the problem? Okay, so if I do this, okay, let me put some other music. I will do categories. Okay. So yeah. So my first challenge with Rust ownership. That's good. That's pretty good because now it makes sense, and I know that I'm going to the process of real learning the process here. That's good. So let me understand better what I'm trying to do here. I'm trying to get, when I am well, I can move this to the memory, but it do not make sense. So I need a way to copy PU, but I don't want to pass PPU as parameter of writing the byte. So let me check here. Struct with mutable reference field. I'm very confused about Rust. If I have a mutable bind to struct and a struct table bind and the struct contains field that's mutable reference, I can mutate the reference. Well, if I have a immutable binding, okay, here, and if that's a mutable, then I can mutate, but not through the immutate binding, but not an immutable reference. This is illegal because binding is immutable. Is mutable binding, you cannot change VOHF itself because the reference of type. Since X is a bound mutable and gives you the value bound to X, it always works. In other words, modifying the value behind the reference changes exactly nothing about the reference itself. This question is not exactly what we are having here, so let me search. So this is so simple. I have the mutable reference here. But what I want is the reference for a field. So let ppu equals self ppu. I think that this PPU should, I mean, if I do this mutable, then I do this PPU dot and now I can't. I can do this. Actually, let's see what's the comparison. Cannot move out of board content. Help consider. Oh. This is weird because self itself is a reference. If I do this, then if I do this, okay, let me check. PPU is a reference, so the data it refers to cannot be borrowed. Okay, but what happens? So let them do this. Anyway, to do the same error because PPU is a reference. And now, okay. I cannot. No. At this moment, I have a reference for the PPU. Self-view table because it's a red bar pressing table. Let me check it. Let equals to south. Okay, so this cannot borrow self as in table because so this is being considered as but I'm not barring the self itself. Let me do something. But call PPU masterization. So actually self view.
I'm gonna be myself, I'm gonna be someone else. I'm gonna skip my breaks, I'm gonna make mistakes. I'm gonna skip my breaks, I'm gonna make mistakes. I'm gonna be myself, I'm gonna be someone else. I'm gonna be myself, I'm gonna be someone else. I'm gonna skip my breaks, I'm gonna make mistakes. I'm gonna skip my breaks, I'm gonna make mistakes. Try not to hold me down, feel alive when I'm in this town. Look at those beautiful stars, I wanna drive a faster car. Nothing can break me, no, no, nothing can break me. Try not to hold me down, feel alive when I'm in this town. Look at those beautiful stars, I wanna take a trip to Mars. Nothing can break me, no, no, nothing can break me.
So maybe this way. Okay, I will do this and I do like self. What's the problem here? Has I'm not moving. I'm getting. Okay, then what's the problem? Like that. CPU, a smooth table, and sit behind. I cannot borrow mutable, something that is not mutable, but if I put mutability here, it's not a problem. I thought this.
Let's say I let you call me baby. Let's say I let you hold my hand. Let's say I let you stay for coffee in the morning, 'cause you spent the night right next to me. Let's say I let you buy me dinner. Let's say I let you meet my friends. Let's say I let you have my number. Well, I guess this time I didn't stand a chance. Oh no, I am not in love, I am not in love, no. He was nothing but a city boy.
So here the nothing is true method take the ownership of self. Oh, it takes ownership. However, self cannot be moved because borrow only provides which borrow content. So
Let's say I think about you once or twice. Let's say I want you to want me. Maybe someday you feel the way I do.
yeah, anyway, let me do this and check if this like half. So
He was nothing but a city boy. Nothing but a city boy. So what? Now. Nothing but a city boy.
oh, sorry.
He was nothing but a city boy. Nothing but a city boy. He was nothing but a city boy. Nothing but a city boy. So what? Now. Nothing but a city boy. So what? Now. Nothing but a city boy.
If I do this mutable, then I have the same problem. why I need table structure reference to get mutable field. Sometimes data structures need to mutate one or more fields. Yeah, this is the okay, so let me get to the bug. I think I will need to understand better this, so I will read this. So, interior mutability is a design pattern in Rust that allows you to mutate data even when there is an immutable reference to that data. Normally, this action is disallowed by borrowing rules. Borrow. How can I pronounce that? Borrowing. Sorry, not boring. Boring is me. Borrowing. 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 So it's disallowed by borrowing rules. To mutate the pattern, use unsafe code inside a data structure to bend Rust's usual rules that govern mutations and borrowing. We haven't yet covered unsafe code. We will in chapter 19. We can use types that use interior mutability pattern when we can ensure that the borrowing rules will be followed at runtime, even though the compile can't guarantee that. The unsafe code involved is wrapped in a safe API and the outer type is still immutable. Let's explore this concept by looking at a half-cell type that follows the interior mutability pattern. Enforcing borrowing rules at the runtime with half-cell. Unlike RC, the half-cell types represent a single ownership over the data it holds. So what makes half-cell different from a type like box? Recall the borrowing rules you learned in chapter 4. At any given time, you can have either but not both one mutable reference or any immutable reference. Reference must always be valid. With references and box T, the borrowing rules invariants are enforced at compile time. With half-cell, these invariants are enforced at runtime. With reference, if you break these rules, you get a compile error. With half-cell, if you break these rules, you panic and exit. Okay. The advantage of checking borrowing rules at compile time are that errors will be caught sooner in the development process, and there is no impact in runtime performance because all the analysis is completed beforehand. For those three reasons, checking the borrowing rules at compile time is the best choice for majority of cases, which is why this is Rust's default. The advantage of checking the borrowing rules at runtime instead is that certain memory safe scenarios are then allowed, whereas they are disallowed by compile time check. Static analysis like host comparison and conservative. Some properties of the codes are impossible to detect by analysis code. The most famous is halting problem, which is beyond the scope of this book? Okay. Because some analysis is impossible if Rust compiles can't be sure that compiles with ownership, so it might reject a program. In this case, it's conservative. If Rust accepts incorrect, okay. Age was the type of reference useful when you are sure your code follows the borrowing rules, but the compile is unable to. Okay, similar to. Here is a recap of the reasons. E is only for using okay. Here is a recap of the reasons. Hmm. So here we should do something like. Let me check if I understood. Have cell PPU. Do I need this now? I don't think I need it. Okay. Mm-hmm. Yeah, but in this case, it will have the ownership of. I don't want the ownership. Hmm. Well, let me do this. And then I do. Okay. I can use it later. Yeah. Okay. So then. Okay. So here I can do like this. Self. Oh, the music stopped. Sorry. Then it get boring. Yeah, let me put the old but good video game. Yeah, I like those musics. Yeah. So then here I can do something like this. Borrow mutable. Yeah. Then everything works. Or not. Oh yeah, now I have a, so apparently we saw, let's see. PPU here. What's there? Uh, yeah. Did you mean have cells filled? What's that? Oh, sorry. Yeah, then this. Yeah. Value board after. Ah, yeah. So this is something. Anyway, I can't do this. So. Okay, so let me see here. So let me do this. F cell, new. Okay. Then I need to do this all the time. That should be mutable. I'm not understand here what's the problem. It should be mutable, yes. So that mutable CPU. Understand here. Still not very bored. So it's not expected mutable reference found. Consider boring here like this. This is weird, because as far as I know, so PPU borrow mutable. So borrow So let me do this. So let me do this and CD her here. If I do half mode, okay, now cannot borrow a smooth table. No. Oh wait. Then here I can have like okay. Here we have A. And here is okay. And then here I do CPU. What's that? No. So this is not right. Not first place. Okay. So here we have the explicit lifetime needed. No method named phonotype. Okay, where is that? Here. Yeah, here I already have that. CPU is borrowed here. Yeah, that's crazy. I think you need to learn more about this borrowing. Because I thought... Oh, it will fail anyway. Yeah. Let me move back. Oh, this is still... Yeah. No. Okay. Yeah. So I'm back to the beginning. I need to stud more. Yeah, so how can I solve this? How can I work around this? Yeah. So here, mutable borrow occurs here. Immutable borrow ladder call. Let me do something just to see it's like that. Let's just say that way. Why that's the problem? Okay, I just want to... I cannot even... Okay, let PPU. Okay. So now I'm not passing anything. Just to see if it compiles. compiles. Oh, I didn't. That's. Anyway, I can't do that. Yeah. So the problem is much bigger. What if I create a PPU here inside? I don't use PPU here. And I only use PPU here. Okay. So I will do something different here. I don't know if that is the best way. How I will do this? I will do this. Oh. Let me make this public. Yeah. So then I can do. So I will actually hold the PPU, the entire PPU inside the memory management. So doing this should not be a problem, or it still is. Okay, so this way it will run. Okay, I don't need the lifetime anymore because I'm not holding a reference of PPU, but I'm having the PPU itself inside the MMU. That's not the good way of doing that, I know. I will refactor that. I will put some comment here. Find a better way of doing this. And let's see first if this will work. Oh. Well, the same problem. The very same problem. Cannot borrow self PPU as mode table because it's a RAM. Then again, the same problem. Oh my gosh. Mutable borrows occur here. Immutable. Yeah, that's weird. But now I own this. So what about I do this? This is not a reference anymore. Why it cannot be the reference? Well, this type doesn't not exist. Is a reference, so the data represents. No. Yeah, guys. Folks, yeah, another ending of frustrating end of stream because still not get this done just because of the boring stuff. I mean, borrowing stuff. So yeah, I will not commit this because it's not. Commit and display status. Working on calling PPU methods from facing ownership problems. So yeah, today it's one for Rust ownership system and 0 for us. I need to understand more how to do that. I promise you I will learn, and tomorrow I will try to have a solution for that. I need to turn off now. And anyway, the video recorded for this will be in YouTube, and tomorrow we have the same show at this time. Okay, thank you for watching and see you tomorrow.